Welcome everyone. In this video, I will be covering section 10.3 polar coordinates. So we have seen Cartesian coordinates before, and what do you mean by polar coordinates? Here, if we choose a point in the plane that is called the pole, so it is in the figure, it is this point over here, or origin, and is labeled as O, then we draw a ray half line starting at the origin or at O, called the polar axis, is shown in this figure. This axis is usually drawn horizontally to the right and corresponds to the positive x-axis in the Cartesian coordinates. That is this line. It's called the polar axis. If P is any point in the plane, and R is the distance of O to P, R is the distance of O to P, and let theta be the angle, usually measured in radians, between the polar axis and the line OP, as in figure 1, then the point P, represented by the ordered pair R, theta, and R and theta are called the polar coordinates. Are called the polar coordinates. We use the convention that the angle is positive. This is our usual convention from trigonometry. We use the convention that the angle is positive if measured in the counterclockwise direction. If measured in the counterclockwise direction from the polar axis, and negative, it's negative, the angle is considered negative if it is measured in the clockwise direction. If P and O coincides, then the distance between O to P is 0, so R equal to 0, and we agree that R comma theta, which becomes 0 comma theta, represents the pole for any value of theta. We extend the meaning of polar coordinates R comma theta to the case in which R is negative by agreeing that in figure 2, the point negative R theta, if you look at this point, negative R theta, and R theta lie on the same line through O, and a distance absolute R from O, but on opposite sides of O. So R comma theta, if R is positive and R and theta will lie in the same quadrant, R theta lies in the same quadrant if R is positive, and if R is negative, then it lies in the quadrant on the opposite side of the pole. So notice that negative R theta represents the same point as R comma theta plus pi. So R theta will lie on the same quadrant as theta if R was positive. And if R has to be negative, then it lies on the opposite side of the pole, but along the same radial line. So from R theta to negative R theta, if you have to move, then you have to rotate through an angle of pi. So it is negative R theta is also represents the same point R comma theta plus pi. Let's now take an example where we try to plot these points in terms of polar coordinates. Example 1, plot the points whose polar coordinates are given. 1, 5 pi by 4, that is part A. So we have to first draw the polar axis. Let's take O to be the pole, and this is the polar axis. Then in this, from here, from the pole, from the polar axis, you have to move 5 pi by 4 anti-clockwise because theta is measured positive if it is measured anti-clockwise. So it is pi by 4, which is 45, and then 2 pi by 4, which is pi by 2, 3 pi by 4, 4 pi by 4, which would be 5. Then we are going here 5 pi by 4. So there's this line here. We are going from polar axis to this, which is equal to 5 pi by 4. In this line, in this radial line, you're going to measure a unit, you're going to measure a length of r equal to 1. So it is r equal to 1, r equal to 2, and so on. So this particular point represents 1 comma 5 pi by 4. Then B, 2 comma 3 pi. So let's try part B, which is 2 comma 3 pi. So start off with the pole and the polar axis. And then in this, you are going to move 3 pi, you are going to measure 3 pi units, angle, 3 pi radians. So you are going to have, so it's pi by 2 here. This is pi. So if you go from here to here, it is pi. From here to here, it is 2 pi. From here to here, it is 3 pi. So this is 3 pi. The angle is 3 pi. So you are along this way, along 3 pi. In this, you are going to mark 2 units. Here you are going to mark 2 units. So measure 2 units along that direction. 1, 2. It is 2 comma 3 pi. This point. Let's try 2 comma negative 2 pi by 3, which is part C. Start with the polar axis. O is the pole and this is the polar axis, which is a radial line, half line from O. So now you are measuring 2 pi by 3 in the negative direction. So pi by 3 is 60. That is 60. Then you're going to have pi by 3, 2 pi by 3. 3 pi by 3 will be pi. So you're going to measure, this will be pi if you measure anti-clockwise. So you're going to divide this into 3 parts. 1, 2, 3. So you're going to have, this will be negative 2 pi by 3. So you are in this line, negative 2 pi by 3 line. And you're going to measure 2 units there. So it's 1, 2. So it is 2 comma negative 2 pi by 3. Is this point. Next, let's try negative 3, 3 pi by 4. That is part D. Start with the polar axis, pole and the polar axis. Then you are going to measure 3 pi by 4. This pi by 4, 45, pi by 2, 90, then 3 pi by 4. You are in this line. You are in this line, this 3 pi by 4. In this line, but you are moving away from the pole, which is -3. So you have to extend this line, then mark 3 there. So it will be, this point would be -3, 3 pi by 4. So here if you notice, in fact, the complete counterclockwise rotation is given by an angle 2 pi. The point represented by the polar coordinate r comma theta is also represented by r comma theta plus 2n pi. So one complete rotation brings back you to the same point. And also in terms of negative r comma theta can also be obtained by changing negative r and theta plus 2n plus 1 pi. If you add an odd multiple of pi, they get to the same negative r theta. If you add an even multiple of pi, you get back to the same point. So with these notations, we notice that polar representation of a point is not unique. So when you say 2 comma 3 in Cartesian coordinates, there is only one way of representing 2 comma 3. But we notice in these problems, there are several ways of representing the same point. Connection between polar and Cartesian coordinates. So let's take r comma theta in polar coordinates, and we will keep polar axis as x-axis, and we consider the y-axis. So we will consider this in standard form. So here you are going to have cosine theta is adjacent over hypotenuse in this triangle, so which becomes x divided by r from the triangle. Adjacent over hypotenuse, so it will be x divided by r. Sine theta will be opposite over hypotenuse, so it's y divided by r. So x can be written as r times cosine theta, y can be written as r times sine theta. These equations are valid for all values of r and theta. In addition, we use the equations r square equal to, what is r square from the triangle? Pythagorean, if you apply the Pythagorean theorem, you can write r square as x square plus y square. And what is tan theta from the triangle? It's opposite over adjacent. So tan theta equal to y over x. So we'll be using this quite often in our conversion of polar to Cartesian and Cartesian to polar. So let's try an example based of these results. Convert the point 2 comma pi by 3, which is obviously polar, to Cartesian coordinates. We are changing r comma theta to x comma y. So let's use the result that we have mentioned here. X equal to, we have to find out x and y. So if we write x equal to r cosine theta, but r equal to 2, cosine of theta equal to pi by 3. So cosine pi by 3 is 1/2. So this is equal to 1. X equal to 1. Now let's find out y. Y is r sine theta. R is 2. Sine of pi by 3, 2. Sine pi by 3 is root 3 over 2. So this becomes root 3. So y equal to root of 3. So you can find out the Cartesian coordinates. You can write the Cartesian coordinates x comma y. corresponding to 2 comma pi by 3 in polar is 1 comma square root of 3. When theta lies in the first quadrant, when theta is acute pi by 3, then you will get a value in the first quadrant, provided r is also positive. So 1 comma root of 3 is a point in the first quadrant. Now let's try example 3. Represent the point with Cartesian coordinates 1, negative 1 in terms of polar coordinates. So what is given here is x comma y Cartesian. You're going to write this in terms of r comma theta. So let's use the relations connecting polar and rectangular coordinates or Cartesian coordinates. So we know that r square equal to x square plus y square. So x is 1, y is negative 1. It's 1 plus 1, which is equal to 2. So r equal to square root of 2. Then you're going to find out tan theta. So we know that tan theta equal to y divided by x, y equal to negative 1, x equal to 1. So it is equal to negative 1. So theta, you're going to find out the suitable theta here. If tan theta equal to negative 1, then theta equal to inverse tan of negative 1, which is equal to negative pi by 4. If you are writing this in as an anti-clockwise direction of theta, if you want to make it a positive angle, so this is the angle in the fourth quadrant. So you can also write, if you want to make it like positive, then you can consider this to be theta equal to 7 pi by 4. You can also write like that. It is in the fourth quadrant. Suppose you measure it in the uh, clockwise. So let's say pi by 4 is here. Negative pi by 4 if you write like this. But if you measure like this, the clockwise way, that is going to be 7 pi by 4 or 2 pi minus pi by 4. You can consider that to be 2 pi minus pi by 4, which is 7 pi by 4. This will be theta positive. So you can actually write this you are going to write this in polar coordinates. Polar coordinates of this point, polar coordinates corresponding to the Cartesian coordinate 1 comma negative 1 is x comma y, uh, r comma theta. X comma y is 1 negative 1, r equal to radical 2 and theta equal to negative pi by 4. That is one way. Or you can also write radical 2 and 7 pi by 4. So keep in mind that theta lies in the x comma y lies in the fourth quadrant because x positive, y negative. So you are going to choose an angle corresponding to the fourth quadrant angle. So that will be either negative pi by 4 or in the in the anti-clockwise it is 7 pi by 4. Here, the important thing to remember in the problem that we have done, choose theta so that the point or theta lies in the correct quadrant. So here, the reference here is this value. This point lies in the fourth quadrant. So your angle should represent an angle in the corresponding quadrant. Hope this video helps, and I will be continuing with this material for in part B of the concept video for 10.3. So please watch the second part of the video for 10.3.